Okay, promise this is the last screencast and this one will be faster than the other ones. So if you think of conjugate pairs, we talked about this first semester. So when you have a conjugate pair, like if you had x plus the square root of 7, the conjugate pair would be x minus the square root of 7. So remember, the first term stays the same. The second terms just have different signs. Yes, they have different signs. So we will use this when we are talking about polynomials. If you notice that in the last section when we were finishing up the notes, I'm just going to come back over here to the end of the last page. You'll notice that when we use the square root method or when we use the quadratic formula, we ended up having conjugate pairs, right? Plus or minus 5, plus or minus root 7, 3 plus square root of 2, or 3 minus square root of 2. So let's talk about this a little bit more in depth. So if I'm told that a 0 is the square root of 7, what is another 7? What is another 7 that I absolutely know? I'm hoping you came up with this on your own, but it would be negative square root of 7. And so if I was going to try to write the factors from each of those, remember if this is my 0 and I'm going back to a factor, remember if you had like x equals 4 is a 0, if this is your 0, then your factor would just be x minus 4. So here, if I'm told that the square root of 7 is a 0, then x minus the square root of 7 is going to be a factor. And if negative square root of 7 is a 0, then I know x minus a minus, which would be x plus the square root of 7, is also a factor. So both of those would be factors from these two polynomials. Now, if we're given that a 0 is 3 plus the square root of 5, what is another 0? And I'm hopeful you're coming up with 3 minus the square root of 5. Now, this gets a little tricky trying to write our factors because we're really just going to do x minus whatever the 0 is. So the first factor is going to be x minus 3 plus radical 5. And the other factor is going to be x minus 3 minus radical 5. That looks really yucky, and could you imagine multiplying all that across? It'd be a little bit challenging. So last but not least, I want to talk about what happens if we have a complex number. If we're told that a 0 is 6i, what's the conjugate pair of 6i, which means what's another 0 that has to be there? And it would be minus 6i. So let's talk about what are the factors here. These are a little bit easier than the one we previously saw. Our first factor would be x minus 6i, and our second factor here would be x plus 6i. Now, the reason that we say all of this is that we will need to multiply some of all of these. And so there's an easier way to do it. And what it's called is the sum and product property. And what it says is that if you are given two zeros, you actually have a quadratic that comes from these two zeros, and the quadratic is always going to be x squared minus the sum of the zeros times x plus the product of the zeros. So I want to go through an example first with just rational numbers that we know and it's easy for us to do. What if I told you that the zeros were x equals 5 and x equals 3? Using this sum and product, we could take the sum of these two zeros, so 5 plus 3, and that gives me 8. The product of these two zeros, so really I'm just multiplying the two zeros together, so 5 times 3 gives me 15. And once I can put this all together, taking the sum of the zeros and the products, and my quadratic is going to be x squared minus the sum, so minus 8x, plus the product, which is 15. Now, another way, and what you've been doing before, if you know you have a 0, x equals 5, and x equals 3, we can actually make the factors. If a 0 is x equals 5, we know that the factor is x minus 5. And if we know the 0 is x equals 3, then our factor is x minus 3. And if we FOIL this out and combine our outer and inner terms, we would end up getting x squared minus 8x plus 15, which is exactly the same thing that we got using the sum and product. So you may be asking yourself, Miss Elrod, why did you do that for these zeros that we were given? And typically you may not do sum and product there, but you definitely are going to want to do sum and product when you are talking about irrational zeros or if you're talking about complex zeros. So here they want us to write a polynomial with the least degree that has zeros at x equals 7 and x equals the square root of 3. So when we have a 0 at x equals 2, the factor that comes from is x minus 7. Okay. Now, if we have a 0 at x equals the square root of 3, what is another 0? What is the conjugate pair? And I'm hoping that you all realize that is x equals negative 3. So we have these two zeros, and we could come up with the factors, but it's actually easier to create what I call a mega factor using the sum and product. So if I'm trying to find the sum of these two zeros, I'm just going to add the square root of 3 plus a negative square root of 3. And 3 plus negative square root of 3 is just going to give me 0. And then next, I want to do the product, or I want to multiply these two zeros together. So I have the square root of 3 times the negative square root of 3. And that's just going to give me negative 3. So when I write what I refer to as the mega factor, I'm going to use sum and product. So it's going to start with x squared. It's going to be minus my sum, which here is 0 times x, and then plus my product of my zeros, which was negative 3. Now I'm going to go back and clean this back up because I don't need to include that 0x. So this ends up just being x squared minus 3. So ultimately, if I'm trying to write the equation of the polynomial, it's got to include these factors, the x minus 7, and then that mega factor, x squared minus 3. That x squared minus 3 includes both of those irrational conjugate pairs. Okay, so actually we're going to go through this one together. So this next one tells us we have a 0 at x equals negative 3. And if we talk about that, actually I may just write this right here. So we know our zeros are at negative 3. So if that's our 0, then our factor is going to be at x plus 3. Now the other 0 that we know is 2 plus the square root of 3. So if 2 plus the square root of 3 is a 0, then we also knew 2 minus the square root of 3 is a 0. And we can use sum and product to come up with what I call the mega factor. So the sum of these two zeros is going to be 2 plus the square root of 3 plus 2 minus the square root of 3. And it's kind of nice because those square roots go away, they cancel each other out, and we're just left with 4 for the sum. And then our product, if we multiply these together, 2 plus the square root of 3 times 2 minus the square root of 3, we're going to notice that we have the difference of two squares. Because our outer and inner terms are going to cancel out, we've got 4 minus 2 square root of 3 plus 2 square root of 3 and then minus 3. So the outer and inner terms cancel out and we're just left with 4 minus 3, which is just 1. So now putting it all together to come up with our factor, we have x squared minus the sum, so minus 4 times x, plus our product, which is just 1. So we're going to take this mega factor and our other kind of ordinary factor to write our equation of our polynomial. So our polynomial is just going to be x plus 3 times x squared minus 4x plus 1. Now, in both of these instances, in the previous example and in this one, we could multiply this all out to get our equation in general form, and that's totally fine as well. It just depends what is necessary.